Okay, so I guess today we are going to look at the Weibull module. So that's a module which, as you know, if you have AvSim or if you have RCMCost, it's just provided along with those modules as standard. And what it allows you to do is import your historical failure data, do a line fit to that data in order to predict the failure parameters for a particular type of component or component failure mode, and then use those results as part of your RCMcost or your AvSim analysis. So this is the Weibull module that you can see here. You can see that the tree control is very simple. All you need to create here are Weibull sets. A Weibull set is the object in your file that will contain your historical failure data. So I will start by creating one of those. So I'll create a Weibull set. Now, a Weibull set allows you to set up a variety of options that will be used when you analyze the incoming failure data. So I can access those options on the Analysis Options tab. Now, the two most important sets of options are the life calculation method and the reliability estimation method. Life calculation method is basically telling the program what format your data is in. There are two formats, user specified life and failure or suspension date minus installation date. So for the first method, let's say, for example, you've been using a particular type of pump for a number of years, and every time one of those pumps has failed, you've made a note of how long it lasted for. So maybe the first pump lasted for 1,000 hours, the second lasted for 1,500 hours, and so on. If you select method 1, that's the type of data you will be importing, just a single column of times to failure for a population of identical components or identical failure modes for a particular type of component. The alternative is method 2, which is maybe a little bit more like what you've been doing already, where instead of just logging the time to failure, you log the time of the date of installation and the date of failure for each of the components in the population. So you would have two columns, one of installation dates and one of failure or suspension dates, where suspensions are, they basically represent components which did not fail but were removed from the system before failure, maybe because of a scheduled replacement or because you had reached the end of the system lifetime before that component failed. So I will start by demonstrating method 1. The other is reliability estimation. What the program does, when you import the times to failure, it will automatically plot that data on a cumulative probability plot. Basically, it will use the time values that you import to estimate the corresponding unreliability of the component at that point in time. And the method it uses to determine that value of unreliability is the method you choose here. The default is median rank. That means the program is estimating unreliability with a confidence of 50%, hence the median. There are also options for 90 and 95% confidence. And there is also the Nelson method. I think the Nelson method is more commonly used with relatively poor data sets if you've not got very many data points. But by far the most commonly used is the median rank, and that is the default that we set. So in most cases you probably wouldn't have to change this. So of course there are options for precision.
The Nelson method would be...
I'm sorry?
I have a question. Yeah, just wanted to ask for the Nelson method. We use it for the poor data sets, or like if the data is not enough?
Basically, yes. I think that's the most common use for it, is if you've not got very much data, maybe just a handful of points.
Okay, because most of our data, like for each equipment, we have like maybe 7 to 8 failures in like last 15 or 20 years.
I see.
So for that, you would recommend I would go for Nelson?
I think in that case you could probably keep the median rank. So you'd be, because I think the results would be fairly similar. But I think for 7 or 8 points you'll probably be okay. But unfortunately, there's no sort of hard and fast rules for it. It's more just what I think there's a handbook on Weibull written by the guy who actually invented it originally. There may be some pointers there. But I mean, there are methods here for dealing with data sets where there are only maybe 1 or 2 failures. You maybe have quite a lot of suspended data, a lot of components which did not fail, and only a couple of points where they did fail. Maybe that's a better time where you might use the Nelson method and some of the other methods provided.
Okay.
Okay. The other option here is for the B and P life. Basically, the way this works is with the B life, what you would do is enter a percentage value of unreliability. So, for example, for B1, I've entered 10%. What the program would then do is when you do the analysis, it will return the time at which the component is estimated to reach 10% unreliability. And you can do that for 3 different values of unreliability. There is also the P-life, which is sort of the reverse of that, where you would enter a time value, and then the program would tell you what the estimated unreliability is at that point in time. So I will create that data set, and you can see it appears here, but currently it's empty. There's no data in there. So
one more question.
Go ahead.
Yeah, the P value would be the number of hours after commissioning, right?
Yeah, well, it's really the number of hours after the 0 point on the time axis. That wouldn't necessarily correspond to commissioning, because the data that you input to the analysis potentially could be for components which at the point of startup were already 1,000 hours old or 1,500 hours old. So it's not necessarily from the point of where the component was brand new, but I guess from the point at which you started using it. So if that's what you mean by commissioning, then yes, but it's not necessarily from the point where the component is brand new.
Okay, got it.
Okay, so I'm going to find some example data, if you bear with me for a moment. Okay, so that was useful. So I've got some data here. I'm going to use this valves data set. So in this case, the data is very simple. It's just a set of times to failure. So this component maybe lasted 25,600 hours, and this one lasted 14,600 hours, and so on. So there are a couple of ways of getting the data into the software. I'm going to use the clipboard to do it in this instance. So I will copy the data to the clipboard. I've got 50 data points. Then I will go back to the program, select my Weibull data set, and in the grid view at the bottom here, I'll right-click and I will paste from clipboard. So what I'm basically doing now is importing data from the clipboard, and this works similarly to the import data facilities that I think we've probably discussed previously. All we need to do is tell the program that the clipboard data should be placed in the Weibull set items table. You can see it's created a link, and then tell the program that the data itself, the data column, should be placed in the time value column. Then I can import and close that dialog down, and you can see the program has imported that data. You can see it at the bottom there. and on the plot the program has automatically calculated unreliability estimates using the median rank method that we selected. So now what we need to do is basically perform a line fit of this data. Now there are a variety of different distributions that you can fit that data with, and you can see them there. So you've got simple things like exponential, where you would just get an MTBF, Weibull distributions, where you would get various Weibull parameters, and some other options there as well. I'm going to use the 2-parameter Weibull distribution, but it is worth mentioning that you can ask the program to recommend a distribution, but you do have to use some discretion when you're using that facility. It's very good when you have a lot of data. When you don't have so much data, it's maybe less reliable. So you can try it. You can just hit the button and let the program recommend a distribution. But you should always think about whether or not you believe the selection that the program has made. Does it make sense to you? Do the parameters make sense? But for the most part, if you've got not much data, so as you said, you've got maybe 7 or 8 data points, it's probably best to think about, okay, how do I expect this thing to behave? Then maybe make a selection accordingly and then go from there. So I might say, well, I know that this component is brand new, so the 3-parameter Weibull is no good because it's telling me, I've got a gamma value that's less than 0. That tells me this component was not brand new. So I might say, okay, I know it's brand new, so that can't be quite right. So and I know it's probably going to wear out, so maybe the 2-parameter Weibull is a better choice. So if I do that and then click the calculate button, the program does a line fit to the data and gives me back these parameters here. So I've got a characteristic lifetime of 12,000 hours and a shape parameter, beta, of about 2, which is telling me that that's wearing out. I'm getting a failure rate that increases with time. A couple of other things that are worth pointing out are the 2 parameters here. Rho, or the correlation coefficient, is basically a byproduct of doing a linear fit to the data. So the program uses regression to do the fit. It generates a correlation coefficient during that analysis, and the closer to 1 that value is, the better the fit to the data. Also, we have the goodness of fit parameter. The closer the goodness of fit parameter is to 0, the better the fit. These are actually the parameters that the automatic fit uses to make its decision. It tries to get rho as close to 1 as possible and epsilon as close to 0. But of course, if you've not got much data, a distribution with more degrees of freedom is likely to fit that data better than maybe a more correct distribution. So again, you have to be careful if you decide to try and use this option. Okay, so we've imported our data and we've chosen the distribution, fitted the data, and we've got these parameters back. So what we can do now is, let's say we go to AvSim, for example, create a failure model, and on the failure tab, instead of selecting a distribution and entering the data manually, we can simply select a Weibull set. And you can see the program pulls in the parameters from the Weibull distribution. And so basically what you're able to do is to do the simulation using data from the real world. So what I might try to do now is maybe demonstrate how this works with work order dates. So I'll create a second Weibull set. You can see this one is empty. I'm going to create a new workbook. I'll call this installation, and failure. And I'm actually going to name this Weibull set, so I'll call that set ID. So I'm just going to put in some random dates. 9. So hopefully that will now just count up. Yeah. And then we'll do 31st, 12. So I'm just putting in some dates to make this relatively easy. So just assume every component lasted for a year. That's probably very silly, but we'll do it anyway. Weibull set 2. So this is actually now telling the program explicitly which data set to use. So we'll save that. So now what we can do is if I close that, I will go into File and Import. I'm importing from Excel. I'll just go and find that WS2. Oops, there we go. There it is. So I need to match that to my Weibull set items. And then my failure matches the failure date. Installation matches installation date. Set ID equals Weibull set. And then import. What's gone? I think I know what I've done wrong. So I think probably there I would also need a subindex, I think, but we'll see. So that just enumerates the data points in the Weibull set. So let's try that again. Subindex. Okay, and close. So you can see there that the program has imported that data. So, and you can see basically it's done that analysis, and it looks a little bit strange basically because they've all got the same amount of time to failure. But you can see there in principle that you can import installation and failure dates just in the same way you can import a straightforward time to failure. And you can see that the program has fitted that with a 2-parameter Weibull. I might be better off fitting it with maybe an exponential distribution. I've got my mean time to failure, which is about 8742. But yes, basically that's an overview of the Weibull module. There isn't very much more to it than that. I mean, do you have any questions about it at all?
Yeah. One question that I have is, we have failure data from 2000 onwards, so that's exactly like 14 years, right?
Okay.
But we do not have the installation date for each equipment separately. So for reference, can we just do starting date or installation date for all the equipment like 2000 onwards, or do we need to ask the client about what's the installation date for each equipment separately?
If you want a really accurate analysis, then it's a good idea to know what the installation date is, because you could have, say, a point where you've put in an installation date of 2000 and it's failed in 2003, but if the real installation date was 1997, then that data point will not be accurate. So either you would need to find out how long each component lasted, so you could import it just as a time to failure, or I think you really would need to know what each installation date was. I mean, in this example, are we talking about lots of components which are functioning simultaneously, or are these all components which replaced each other each time there was a failure?
Different type of equipments that's functioning simultaneously. Yeah.
Okay. Yeah, because I was thinking if it was just, say, one equipment in the system which was being replaced or repaired, you could just use the failure date of one component as the installation date of the next one, and that might be a reasonable approximation. But if they've been running side by side, then I think unless they were all installed at the same time, it's a good idea to find out what the installation date is for each one. I mean, if they were all installed on the same date, then that's fine. They can all have the same installation date. That's no problem. But if that's actually not the case in the real world, then it's a good idea to try and find out what the real dates are.
Okay.
So are there any more questions at all?
That's okay with us, so you can go ahead.
Again,
that's
really it. It's probably, maybe it's worth me showing you just that you can view other plots here. For example, you can see a plot of the estimated failure rate against a regionalized failure rate plot, which is based on your failure data. So you can get a rough idea of how well the data fits. And there is also the the probability density function, which just shows you the PDF, the probability density function for your theoretical fit. So this is based on the parameters that are coming from the fit. So yeah, it should maybe just useful to know that those are there. But otherwise, that's it really. That's everything I think that I need to show you. If you, again, what I'll do is make this available as a download a little bit later today. But if you do think of any more questions, please feel free to just send me an email.
That's the end of the session, or you're gonna
no,
something else?
That's it. Again, the Weibull module is relatively simple by comparison to the others. It only performs the function of fitting the data that you've seen here and then passing it to RCMCost or AvSim. So where the Weibull module is concerned, really.
I have one more question about the repair times, because
Sure.
if you go to the, I think, maintenance task, you can set Weibull sets there also. So Weibull sets are used only for failure or also for the repair times?
No, you can also use them for repair time as well. So if you've got, say, times to repair, or you've got a failure date and a repair date, you can import that into a Weibull set. And there are distributions here like the Lognormal and normal distributions, which are commonly used with repair times, or the Exponential Distribution. So yes, you can also use Weibull distributions for repair times and for maintenance times as well.
But if we go to the repair time thing, I don't think it asks us for the failure date and the repair date. Rather, it asks us for the same installation date and the failure date. If we just quickly go to the AvSim and then...
I mean, that's right. It says install date and failure date, but it doesn't really matter. That's just a label. This can just as easily be the failure and repair date. You can ignore that in the case of your repair data, because I can just as easily.
Okay, so the install date would be the failure date, and the failure date would be the repair date.
Exactly. So I could just go to AvSim, say, and then in my repair, I could just choose. I can still choose any of these Weibull sets I want, and you can see it pulls in the parameters from there. Okay, so do you have any other questions at all?
Yeah, I think that would be the last question. If we decide not to go with the Weibull and rather just manually insert the failure rates, can we replace MTTF with MTBF? Like, are they the same thing? Because in the software it asks us for the MTTF, the mean time to failure. That would be, I think, for irreparable systems, right?
Yeah, well, the way we do it is we don't do MTBF in the sort of standard sense. We ask for the MTTF, which is the mean time to failure. So in the context of our simulation, what that means is that your MTTF is the time between the end of the last repair and the beginning of the next failure, or the average time, and then the repair time is, of course, the task duration. And then, of course, your MTTF, which you define here, plus your MTTR, which you define here, would give you an MTBF.
But if we go that way, like if we have, for one equipment, we have like 21 or 22 failures, then we have to put what? How many MTTF would we have for those 22 failures? Like 22 MTTF?
I'm not sure.
What we are used to do. Okay, I can explain. What we are used to doing is, for example, if one equipment fails, like say 20 times in 10 years,
yes,
what we do is take the date of the first failure and take the date of the last failure, take the difference and do it, divide by the number of breakdowns. So that gives us the MTBF, like how many failures have occurred in the last 10 years. So we use that value. But since you're saying that we take MTTF for the software purpose, that would be from one failure to the another, right? But for one equipment, we have 20 failures. So that would be what, 20 MTTF values? I'm confused on that part now.
No, you would still only need the one MTTF. If you're going between...
Which one MTTF would be that? Because we have 20 failures.
Mm-hmm. But I think when you do that calculation, I don't think, maybe you're not taking into account that some of the time between, say, failure 1 and failure 2 is taken up by the time required to repair failure 1. So that's why you've got the MTBF instead of MTTF. We sort of split that up, and if you were to use the Weibull module, your installation date would not be necessarily the failure 1 date and then the failure 2. The installation date for failure 2 would not necessarily be the same as the failure date for failure 1, because of course it might take 6 hours or 24 hours to repair failure 1. So each of these should be a time to failure and not a time between failures.
Okay, can we take a small example, maybe just an open Excel file right now, and just for one equipment, say we just list down 3 failures. What would be the MTTF value? Like any random numbers would work. So just to clear up the concepts.
So let's say I have failure dates for failures 1, 2, and 3, and I'll just put those in here.
And it's for the same equipment, right?
Yes, this is all for the same equipment.
Right.
So the component fails, or the equipment fails on this date. Each time we've got the date of failure, and then maybe I will put in, if I move that over, so now I need to think about what the, say, installation date will be. So for my first one, this might be quite easy. It might be, say, the 1st of January 1998, and so I know when it was installed, I know when it failed. The tricky part now is, what do I put here? If you were doing mean time between failures, I would just use this date. I would put that date there, and then if I were to do, say, that minus that, I will get a time between failures. But there is a little problem with that.
Right.
Because it doesn't take into account the fact that actually it took maybe a limited amount of time or a finite amount of time to repair this failure. That would be your task duration.
Right.
So what I'll do is I'll get rid of that. I'll shift this over again, or maybe I'll just put it here. So I'll put repair date, and that might be, say, the 2nd of the 1st, 1999. And 2nd, 1st, and so on. So in fact, the installation date for this one would just be that, and the installation date for that would be the repair date of that one. So then my time to failure would be equal to that minus that, whoops, that minus that. Have I got the right one? Sorry, I'm doing the wrong one. So that minus that, and then equal to that minus that. So basically, in each instance, I would be. So I keep. Yeah, is that right? So in each instance, I'm getting a different time to failure because, of course, I'm taking away the amount of time that's required to actually repair the original component. So that's the key thing. The program is calculating the mean time to failure, not using the point of failure of one failure and the point of failure of the next, but the point of repair of one failure and then the point of failure of the next. So that's where the time to failure is coming from. And then you could say, okay, well, these are my times to repair. And I don't want it to do that. General number. So then I could have these as my times to repair, and then I could fit this data to get my mean time to failure, and fit this data to get my mean time to repair, and then input them into AvSim in the form of my MTTF and my task duration. So I think that's where the difference is. Your method was using the failure of one distribution, the failure of one failure, and then the failure time of the next. Whereas really with MTTF, you're using the repair time of one failure and then the failure time of the next. So does that make more sense?
Okay. Yeah, it does. So for this example, if we have to put one MTTF, right? We need to put one MTTF. That would be the average of this TTF, like these three values. Like if we have to manually put in the software.
Yeah, I think on average that's probably about right. What I would do is probably, you could just take the mean in that case, but I think fitting it with an exponential distribution would do pretty much the same thing. So if I were to import this now very quickly, and I'll do an exponential fit to that. So you can see it basically it's coming up with the mean time to repair, or to mean time to failure. And you could do exactly the same thing with the time to repair as well, though obviously you can see what the mean would be there. Okay, so does that sound okay?
That's fine.
Okay. So are there any other questions at all?
I need to ask my colleague if he has one, if he has a question.
Sure.
one question that my colleague has is when we are done, for example, like these 3 Weibull sets we have made, then we have to go back to the AvSim module and add the failure modes manually, right? And then link them to these 3 Weibull sets. Like we have to add them one by one, the failure modes, right?
Ordinarily, yes. You can also import those relationships from Excel if you would find that easier. But yes, normally you would come in and you would just match them up manually.
Okay, so what you're saying is we can do that in Excel by adding another column of failure modes and then link them up, right?
Yeah, so you could basically do something like this. You would have your failure model ID, the Weibull set, and then you can just put in the IDs of your Weibull, of your distributions, of your failure models, and then of the relevant Weibull sets, and just import that. So that might be another way of doing it as well. Okay, so is there anything else you'd like to ask?
I think we didn't see anything. Maybe the video was stuck. Can you move your cursor? I'm not sure if it's working or not. Yeah, it's working. So what did you do? Because we didn't see anything.
Oh, it was just I wasn't doing anything just now. I was just saying that you could import your failure model IDs along with a corresponding Weibull set ID, and just import that to the failure model table, and then that would give you all of your failure model and Weibull set associations.
Okay. Yeah, I think we're good. Thank you so much. Thank you so much, Mr.
That's no problem. I'll make this available as a download link a little bit later on. And again, if you have any more questions, please feel free to contact me.
Okay, perfect. Thank you so much, Mr. David. Thank you.
No problem. Have a good weekend.
You too.
Bye now. Bye-bye.